ionic bonds. Let's see the learning outcomes first. Describe the formation of positive ions known as cations and negative ions known as anions. Whenever an atom loses electron or electrons, it forms positive ions. Positive ions are also known as cations. For example, lithium belongs to group 1. It forms positive ion with the formula Li plus. The equation will be like this. As it has lost electrons, so I have to show the electron on the right side of the equation. It has lost one electron. That's why I'm showing only one electron with the charge. Let's take one more example. Magnesium belongs to group 2. It forms positive ion with the formula Mg plus 2. Mg plus 2. The equation will be like this. This time atom has lost 2 electrons, so I have to write 2 before electrons, which means it has lost 2 electrons. Now, whenever an atom gain electron or electrons, it forms negative ions. Negative ions are also known as anions. For example, fluorine belongs to group 7. It forms negative ion with the formula F minus. The equation will be like this. F, it is gaining one electron, so I have to show the electron on left side of the equation. And now I will place minus charge on the atom, which shows that it has gained one electron. Let's take one more example, that is of oxygen. Oxygen belongs to group 6. It forms negative ion with the formula O minus 2. O minus 2. The equation will be like this. O plus E, that is electron. Now you will see the oxygen atom has gained 2 electrons. So this time I have to write 2 before the number of electrons gained by an atom. Now, if you look at the periodic table, you will come to know that group 1 metals form ions with the formula M plus, where M can be any of the group 1 metals. This is group 1. They all form ion with the formula M plus, which means they have lost one electron. This is group 1. In this way, you can predict the formula of the ions of other group metals like group 2 and group 3. For groups from 5 till 7, they all will form the ions with negative charge. First, let me show you the chart for the group 2 and group 3 metal ions. For example, group 2, they will form M plus 2. Group 3 also belongs to metal. It forms M plus 3. But for the non-metals, which is from group 5 till group 7, 5, 6, 7, they all form ions with the negative charge. For example, group 6 will form ion with the charge of minus 2. Let's consider N as the element from group 6. It will be minus 2. Remember one point. Consider these should be above staircase line. We know that above staircase line, we have non-metals. So you can predict the formula of the negative ion formed by group 7. It will be N minus. Group 5, it should be N minus 3. Remember this point, the objective of all these metals and non-metals. Here we are having metals. These are our metals. And here we are having non-metals. For forming the ions will be same. That is, metal will acquire stability or full outermost shell by losing electrons. On the other hand, non-metals will attain stability or full valence shell by gaining electrons. So let me write objective of metals and non-metals is to attain stability. By losing or gaining electrons. Of ionic bonds between ions of metallic and non-metallic elements, including the use of dot and cross diagrams. Ionic bonding involves the transfer of electrons or electron to achieve full outermost shell or inert gas electron configuration. It also involves the transfer of electrons from metals to non-metals, which means the transfer of electron is taking place between metal and non-metals. This is the periodic table. You see, these are the metals in this periodic table. This is the staircase line. These are the metals in the periodic table. They form ionic bond with the non-metals. Here we are having non-metals. And they are forming ionic bond. Remember this point. Ionic bond is always formed between metals and non-metals. Ionic bond is always formed between metal and non-metals. It is never formed between metal and metals or non-metal. Never formed between metal and metal or non-metal and non-metal. Well, let me show the ionic bonding by using dot and cross diagram between group 1 and group 7 elements. Here I am taking lithium from group 1. Symbol for lithium is Li, and chlorine from group 7. The symbol for chlorine is Cl. First we have to show the key. I am using dot for lithium and cross for chlorine. Lithium will lose one electron and chlorine will gain that electron. The formula of the ions will be like this. Lithium, after losing one electron, will form ion of the charge Li plus, and chlorine will take up that electron. Let me show the electrons of chlorine first. 1, 2, 3, 4, 5, 6, 7. The 8th electron will be coming from lithium. So it will acquire the charge minus. Dot and cross diagram between group 2 and group 6 elements. I'm taking magnesium from group 2 symbol for magnesium is Mg, and oxygen from group 6, symbol for oxygen is O. I'm using dot for oxygen and cross for magnesium. Dot for oxygen and cross for magnesium. Magnesium will lose 2 electrons and oxygen will gain 2 electrons. So the formula of the ions will be like this. Magnesium, after losing 2 electrons, will form ion of the charge Mg plus 2, and oxygen will take up those 2 electrons and will acquire a charge of minus 2. First, I will show the valence electrons of oxygen. 1, 2, 3, 4, 5, 6. I have to pair up the electrons coming from magnesium, that is 1, 2. Oxygen will acquire minus 2 charge at its heads. It has gained 2 electrons. What if we have a situation in which we are having different groups, like making ionic bond between group 1 and group 6 elements? Now, in this situation, valency will help. Valency is the combining power of an atom. This valency is the combining power of an atom. For metals, valency will be equal to the number of electrons they are going to lose during bonding. On the other hand, non-metals, for non-metals, valency will be equal to the number of electrons they are going to gain during bonding. So here is the valency of all the group elements starting from group 1 and ending on group 7. For metals, we have to place plus sign before their valency. Plus 1 for group 1, plus 2 for group 2, plus 3 for group 3, group 5 minus 3, group 6 minus 2, group 7 minus 1, group 4 plus minus 4. Here's a staircase line also. Remember, group 8 elements are unreactive. This is a group 8 elements. They are unreactive. So they don't form any bond. So there's no concept of valency for this group. Also, valency for the transition metal is not fixed. Where are the transition metals? Here are the transition metals in the periodic table. They are transition metals. The valency is not fixed. It will be provided to you. So leave them also. A dot and cross diagram between group 1 and group 6 elements. I'm taking sodium from group 1 and sulfur from group 6, sodium, sulfur. First, we'll predict the formula using their valency. The valency of sodium is plus 1, sulfur is minus 2. So the formula will be Na2S, sodium sulfide. There will be 2 atoms of sodium. Both are losing 1 electron, so there will be plus 1 charge on each sodium atoms, and sulfur atom will take up those electrons, forming minus 2 charge. 1, 2, 3, 4, 5, 6. A dot and cross diagram between group 2 and group 7 elements. I'm taking calcium from group 2 and chlorine from group 7. The formula will be like this. Predicting formula, we need valency. The plus 2 is the valency of calcium, minus 1 the valency of chlorine. The formula will be CaCl2. It's calcium chloride. Now the dot and cross diagram, there will be 1 calcium atom losing 2 electrons, so it will require plus 2 charge. There will be 2 chlorine atoms, each will taking up electrons coming from 1 calcium atom. So both will acquire minus charge. Now I'm showing their electrons: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Try these questions. Predict the formula between calcium and nitrogen, phosphorus and potassium and phosphorus. Draw dot and cross diagrams between calcium and nitrogen. The SLOs for This video are describe the giant lattice structure of ionic compounds as a regular arrangement of alternating positive and negative ions. State that an ionic compound is a strong electrostatic attraction between oppositely charged ions. Describe, describe and explain in terms of structure and bonding the properties of ionic compounds, high melting points and boiling points, good electrical conductivity when aqueous or molten, and poor when solid. So here's the summary of the last video lesson. Ionic bonding involves the transfer of electrons to achieve full outermost shell inert gas electron configuration. Ionic bonding involves the transfer of electrons from metals to non-metals. Valency is the combining power of an atom. It helps in predicting the chemical formula between different elements of the periodic table. This is the structure of ionic compound like sodium chloride. Sodium chloride. Here's a formula of sodium chloride. Small red balls represent sodium ions. These are Na plus ions, and the large green balls are representing chloride ions or chlorine ions. Whenever ionic compounds are produced, there are lots of positive and negative ions. Lots of Na positive ions and lots of Cl negative ion. So I'm making the small part of this. You know that positive ions repel positive ions and negative ions repel negative ions. Positive ions repel positive ions. Negative ions repel negative ions. In other words, same charge ions repel each other. At the same time, positive ions are attracted to the negative ions or vice versa. Cl negative ion and positive ion and positive ion and positive ion. Cl negative, Cl negative. And these oppositely charged ions rearranged themselves in the form of giant ionic lattice. This is giant ionic lattice. Giant ionic lattice. If you want, you can draw. We have this like this. So if I am placing sodium ion in the middle, the negative ions surrounding this Na positive ions. Like this. In ionic bonding, oppositely charged ions regularly arranged in the form of a giant crystal lattice, which are stable due to strong electrostatic force. Mainly, ions. Therefore, high amount of heat or energy needed to break down the strong forces. So these will be strong electrostatic force, which needs to be broken down. What is electrostatic attraction? It is the attraction either between positive and negative ions, positive and negative ions, or between mobile or free electrons and metal cations. Metal cations. What does higher charge mean? For this, you have to consider the ionic compounds Na2O and MgO. Consider two ionic compounds, sodium oxide Na2O and magnesium oxide MgO. You see in Na2O, there are lots of Na positive and O minus 2 ions. And in case of MgO, there are lots of Mg plus 2 and O minus 2 ions, which means MgO has a higher charge than Na2, has higher charge than Na2O. Now, what happens if one of the ionic compounds have higher charge than the other one? Higher charge means stronger electrostatic forces. Higher charge means stronger electrostatic forces, which means large amount of energy is needed to break down the force. This eventually gives such ionic compounds a higher melting and boiling points. Now here are some properties of ionic compounds. Ionic compounds exist in solid state. Ionic compounds have high melting point and boiling points. Ionic compounds are soluble in water. Ionic compounds does not dissolve in organic solvents. Ionic compounds only conduct electricity in molten state or when dissolved in water and aqueous. Now, why ionic compounds exist in solid state, or why ionic compounds have high melting points and boiling points? It's due to many ionic bonds of strong electrostatic forces between the ions. Many ionic bonds of strong electrostatic forces between the ions. ions or giant structure. Therefore, need a lot of energy. Need a lot of energy to break bonds. Comparing the melting points of two different ionic compounds. Let's compare melting points of two different ionic compounds like sodium oxide, Na2O. The melting point is 1132 degrees centigrade. On the other hand, melting point like magnesium oxide, MgO, has melting point of 2852 degree centigrade. You see the difference in the formula of both sodium oxide and magnesium oxide. I've already explained Na2 for sodium oxide and GO for magnesium oxide. There are a lot of Na positive and O minus ions in case of Na2O. In case of MgO, Mg plus 2, O minus 2 ions, which means MgO has higher charge than Na2O. Higher charge means stronger electrostatic force, means stronger electrostatic force, and hence high amount of energy is required to break the force. Hence high amount of energy is required to break down the force. Now, ionic compounds only conduct electricity in molten state or when dissolved in water or in aqueous. It's due to the reason that in molten state, when ionic salts are heated or when dissolved in water, the ions become free or mobile. Ions become free or mobile. Ionic compounds does not conduct electricity in solid state. In solid state, ions are immobile or not free. Ions are immobile or not free.